Now we're going to discuss file input and output. That is, how to read from files and how to write to files. Whenever I teach programming, this is always my favorite part of the course because now we can start using much larger amounts of data. Up until now, we had to either store our data in our file or prompt the user to give us data to work with, which severely limited how much information we could work with, right? Because of the scalability issue. Now we can read files that have thousands or millions or billions of lines in them and do stuff with them. So in order to work with a file, we need to first open up a connection to the file. And there's several different ways to do that in Python, but I'm going to show you what I think is the simplest way. And then ultimately we want to close the connection to the file. There's several reasons for doing this. One is, if I'm opening up a file and working with it, I don't want somebody else to be able to open up the file and work with it at the same time. At least not in the sense of I'm trying to write to the file and they're trying to write to the file. Whose rights go to the file? Well, typically, if one program has a file open to make changes to it, another program cannot make changes to it. And the operating system prevents that as a security measure, basically, or a safety mechanism. The other reason is that if I'm writing to a file, even though my program may say write to the file right now, the operating system may choose to postpone the writes to the file so it can collect a bunch of the writes and do them all at the same time. So there's no guarantee that it's going to do that when I want it to happen. So once I indicate that I want to close the connection file, that's also an indication to the operating system to go ahead and make those writes. Now files come in two basic forms. There's what we call plain text files and binary files. And I'm only going to discuss plain text files. Your source code that you've been writing up to this point is plain text. Those are the type of programs that store either historically in ASCII the data set or now maybe in Unicode. But they're things that can be easily viewed. You don't have to understand the underlying format because that's a well-known format. So when we make these connections, what happens? Well, when I'm reading or writing to a file, I need to basically do three things. Open up the connection to the file, perform my data exchange, close the connection to the file. But keep in mind that even if you don't plan on reading or writing files on your local computer, those underlying concepts still apply to other data operations. For example, I can open up a connection to a website, download a file, and then close a connection. So conceptually, it's the same process. I may want to write a program that interacts with a database. And so in order to do that, I have to open up a connection to the database, make my data exchange with the database, and then close the connection. So those ideas extend to other forms of getting data or pushing data to some other source. So here's the syntax. And so what I'm creating here, FP, is what's called a file pointer or a file handle. So I'm using the open function. Here's the name of the file. And then here's the mode for interacting with the file. Now, if you're going to work with multiple files, each of those will require a separate call to open as well as a separate call to close and their own file pointer so we can distinguish between them. So here's what I just told you about. We need the name of a file and the mode for accessing the file. The name of the file doesn't have to be hard-coded like this. This just has to be some string. So I could prompt the user for the name of the file to operate on and then use it here. Or I could get it from a file itself. Some other call to open up a file might give me a new file name and then open up that new file or something like that. There's a number of different mode options, but these are the three I'm going to discuss. So R is for reading, and this assumes that you already have a file in existence with the name that you're giving it. If it doesn't exist or it's not in the location where you're looking, which is in the location where the Python executable is at, unless you give it a path, that is, well, then it's going to give you an error message. W is for writing. Now, if the file that you say you want to write to does not exist, it's going to create it brand new. But if the file does exist, it's going to wipe out its contents and write from scratch. So if you had 10 lines there, and now you say I want to write 5 lines, the original 10 are now gone, and all you'll have are the last 5. And then finally, A for append. That allows you to write to the end or append to a file. If the file already exists, then it simply adds to what's already there. If it doesn't exist, then it creates it brand new. So here's a simple program that opens up this file for reading, and then for each line in the file, it prints that line. And then I'm going to close the file. So let's see some of this in action. So let's look at this file that I just created. All right, it contains these lines. Now, reading is the default. So this right here will open up the file for reading. But I like to be explicit and tell it that I'm opening it up for reading. Right? And whenever I have the call to open, I like to go ahead and write my call to close to make sure that I include it. Now, there are some other ways to interact with files in order to open them, but this is my preferred method. Some of those other methods will close the file for you automatically, but whether it's you or some other process that closes the file, it needs to occur. Let's look at what FP is first. So let's print the type of FP. And see, it says it's this class, this text IO wrapper. So as it is now, I can't really do anything with it, because if I try to print FP, that's a file pointer. It's not the same thing as the file content. See, it won't let me work with it. It just tells me something about it. There's the name, there's the encoding. So it's 8-bit characters is really what that's telling me. So let's do what we had before. So for line in FP, print line. And this is a variable name, so I could have said for zebra in FP, print zebra. So where are the blank lines coming from? Well, I'm saying to print the lines, but when you look at this file, there's already new lines in here. Okay, remember that print adds a new line to the end of what it prints, and then there's already new lines here. Because even though you look at this and you think this is 4 lines, in reality it's stored like this. One line followed by a new line, that line followed by a new line. Sorry. And that's what it looks like stored on my computer. And so when I say print it, it's printing this, new line this. In fact, I can show you that. I'm going to do these changes because we're going to go back to this here in a minute. Doesn't matter that I open and close the file and do nothing, it doesn't care. In fact, I'll make a change just to prove this is the same thing. Or that I'm really printing it. So there's 0 on its own line. So if I put a couple of new lines in here, or 3 in this case, I get that right there. All right? So how do we deal with it? Well, remember that since print adds a new line, I can actually suppress the new line using this. And there it is. So it looks like what I did with the cat function, or program, excuse me. All right? So what happens at this point? So I get something like that. Well, these are coming in as strings. So if I say print line, or excuse me, type of line, instead of the line itself, string, 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 because there's four lines in that file. So these, like I said, are just strings, which I showed you when I printed one of those strings. So I would just do what I would normally do. So if I want to tokenize or work with just the beginning or whatever. So if I wanted something like this, if I said only print the first 5 characters of each line. Well, because it's a string, I can slice it. Oops. There's the first 5 characters. I can tokenize. In fact, I do this a lot. So tokens is equal to line.split. And so what's our delimiter in this file? Well, the space. And you can see that when I called tokens, or excuse me, when I split it, what is tokens? When I print, you can see it turn the first line into this list of strings, and this list of strings, and this one. And it also shows the new line that's here. So that becomes a problem at times. So let's say I want to print each of the tokens. Let's see what happens. So I may think, well, I'm going to print each one on its own line. So I say for t in tokens to go through whatever list I'm currently working with. And let's see what this does. Well, see, it has these extra blank lines in here. Because remember, 2 had a new line after it. 5 had a new line after it. 7 and had a new line after it. And depending on the file, was there a blank line in here? There's no blank line, so there's none at the end. So what do I do about that? Well, there's a string library function called strip that gets rid of white space. I discussed it in my string video. So what I can do is I can add here. Or in fact, we can do, so I can do it a couple of ways. Let me do it here and show you this. That works. Or that also works. So what's this doing? Well, strip is a method for strings, so it takes t, it gets rid of the white space on either end, so to the left or the right, and returns a new string, which I printed. So how does this work? Sorry. Where I do this. So what this does is the way it sees it is line.strip, because remember that line, if we look at a file, that first line, 1, 2, looks like this. And I'm going to put it in quotes to make it clear where the string is at. So it's stored as 1 space 2 new line. So the way this is read is line will be this on the first iteration, and it strips it out. So then it returns a new string that looks like this. And then that string has the split method applied to it, which then it splits into this. And that's how we got what we had right here. Except when I did this, I wasn't using strip first. So we could look at that if we wanted to. Comment this out again. And this is a good way to learn, by the way. And even when I'm doing development, it's very common for me to throw in some print statements as I develop to try to make sure that my data is in the form that I think it should be. All right, so there they are. So back to what I was just saying. There's been lots of times that I would help a student debug their code, and they had done a good job of decomposing their program into parts. So they might have said, well, I know I have to do step 1, and I follow that by step 2, and I follow that by step 3, and maybe there's 5 total steps. And then they would contact me for help and say, well, my step 4 isn't working correctly. And I would look at their code and realize the problem wasn't step 4, it was step 2. Like maybe here, they weren't stripping the new lines out. And so then when they eventually got around to working with the data down in step 4, they couldn't understand why it wasn't printing correctly. But the problem was the data that they had was incorrect. Like in this case, I don't want the new line, so I need to get rid of it before I move on to other processes. Or at least that's where I choose to do it. All right, so that's that process for that. What about writing? So here I open up a file for writing. There's a W. In this case, I want to print line 1, line 2 up to line 4. So I say for I in range 1 to less than 5, right? Because this will stop while it's less than 5. I'm going to produce this string. And then I simply write that string because that's what write does. It writes a string. Now, I don't have to have a separate variable for this. I could take this right here and enclose it inside this function call just like I would if I printed a formatted string. But one of the things to keep in mind is that even if you think that you're writing numbers to the file, if you're saving them in ASCII, they really need to be digit characters. So I still need to turn whatever numbers I have into a string in some form, and that's what I'm doing here. So let's write the code to do what this does. Change that to W. And let's do this. So for I in range, and let's do this. And I'm thinking here, that's what I'm doing, right like this. So we'll say S is equal to that right there. So here we'll get the length. So how does this work? Range will get the number 3. And so since I don't give it a starting value or a step value, it knows just to start at 0 and work up to 2. So out string, I'm just doing it this way to make it easier for me to see what the string is. So what happened? Well, I just said print, or excuse me, write, and so it wrote to the file. If you want to see something on the screen, you have to tell it to show you something. So maybe for testing purposes, I might do this. Comment that out. So I might do that until I get the program the way I want. And I say, oh, animal 1 is cat, animal 2 is dog, animal 3 is horse. I say, oh, I don't quite like that. That really should have been this right here, for example. Okay, I got it the way I want. So now I get rid of this line, uncomment this, run it again, and let's look at the file. It was out file. And I notice a problem. What was the problem? Well, as I said earlier, print adds a new line, but if I want a new line here, I have to put it in. So I forgot that. So now I'm going to come back up here. That's where the downside of looking at it with print doesn't help you. And now it looks right. Okay, so I have the new lines in there. And that's all there really is to that. Like I said earlier, if I want to do something else, if I want to try to do this, this is going to be a problem. Argument must be string, not int. So even if I want to just write those numbers to the file, I need to do something to convert it, so I might do this. And if I want to add some formatting, I could do that to space things or whatever. And once again, I didn't have new lines. So if I want the new line in there, there we go. So that's what it takes to write numbers to a file. So numbers come in as strings as well. Let's go back and look at that. So let's say I now want to read that file. So let's say I want to do math with it. Well, then I need to convert to the appropriate thing. So for line in FP, I start like this. Oops, not readable. Sorry, I thought I changed that. And what did we just do wrong? For line in out file, did I wipe out that file? I may have wiped it out. Oh, that's what it was. 1, 2, 3, 4, 5, 6. So when I made the call to open, and I accidentally left the W in there, it just wiped out the existing files. What happened? So there's my numbers. So we got new lines and stuff. So now you say, well, okay, I got my numbers. What if I want to do math with them? So I say my sum equals 0, and we say I'm going to produce the sum of these numbers. So what I'm doing here is technically incorrect, as we'll see. So I say my sum plus equal line. Because I see numbers, right? So I think it's correct, but it's not actually correct. So what's the problem? Well, it started off by saying, let's take 0 and add a string to it. Because 1 is a string, so that doesn't work. So even if I had started with an empty string, now it will append, but not in the right way. So what is this? Well, it's really just those numbers with new lines after it. So they're still not numbers, they're characters. So what do I do about it? Well, I need to convert this. So those are ints. So I'm going to convert each of those characters. And if there were more things on the line, I would have to get the individual tokens. But this should give me just the individual numbers that are there. And that sum is 21. Because 1, 2, 3 is 6, plus 4 is 10, plus 11 is 21. If I work with multiple files, they need their own file pointers. So here I'm opening up this file, call it in file, open up this file for writing, call it out file, and I simply take each line of in file and write it to out file. Now my preference in many cases is actually to read an entire file in using the FP readlines file or method. Because many cases I want to store the data and go back through it, and I don't want to keep opening up the file. So let's work with this, data.txt. We have that file right there. So I might do data is equal fp.readlines, and that's with an S. There is a read line as well, but that's not what I'm using. And let's see what we're in. So there's a list of the lines stored as strings. So there's line 1, line 2, line 3, line 4. So if I want, I can actually do this. So here's how I might process it. I might have these 3 lines of code to read in the data. And I say for X in data, because I'm going to do something with the data instead of printing. I might tokenize or whatever. And you can see I got that right there. And once again, if I want to strip these, In some languages, they use the word trim. In other languages, they use the word strip to get rid of the white space. All right? So this is my preferred method in most cases. Read in the data, store it as a list, because that's what data here is. It's a two-dimensional list, or excuse me, a one-dimensional list of characters, and then operate on that list. So let's talk about a file format called CSV, which is what I probably use most often when I'm reading and writing files. So first of all, it stands for comma-separated values. But really all it is plain text that uses commas as separators. So here I have this file. And so I have 1, 2, 3, 4, 5, 6, 7. Now, if you have Microsoft Office on your computer, it's likely that the CSV extension is associated with Excel. But the underlying format here is just plain text. But you can see it forms natural columns, which is why Excel opens it. But it's not in the Excel file format. If you try opening up a .xls file using Vim, like I'm doing here, then you'd have a problem because it's in binary format, right? So comma-separated values are nice because you can look at them with a text editor like I have here, but they still separate things into commas. But then the next issue is, well, how do I get those things? So you have several options. One is read the lines in like I just showed you and then tokenize. But Python also has a CSV library, which they call modules, that also can deal with it. So let's look at tokenization first. So let's change this to CSV file. Make sure that's the name of the file. It's right here. And now if I want the tokens, what do? So let's start by seeing what we're reading. As I've stated many times before, this is almost always my first step. Make sure I understand what I'm actually dealing with before I write more code dependent upon that. All right, so it's a list. I see some comma separated numbers. I need to get rid of new lines. So what do we want to do with that? If I'm not sure, I may do something like this as well. Take a line and copy it. And I like to put it inside my programs so that way when I come back and use the program, this will help me remember what the underlying structure was because I'm going to base decisions on that. So let's do this. So we'll so X is a line, so I'm going to call it line. I look at the lines. The new lines will be taken care of here in a moment. So let's say I want to sum those numbers up. Well, how do I do it? Well, I'm going to do it in parts. So I'm going to tokenize. So we'll have line.strip. And actually, the int function will take care of that for me, but I'll do it to be explicit split. And what's my delimiter? Well, it's a comma. Now note that what I'm doing by hand means that commas can't be part of a column. The CSV module here can deal with things in which commas are part of the column. Meaning, if you're looking at an Excel file, you might have a single column that has a name like this, Smith, comma, John. But that's one column in the Excel spreadsheet. So I want to maintain the comma as part of that column. But if I look at it in this format, which I just erased like this, well, then it thinks it's just a comma. It separates it into two columns. So typically what they'll do in CSV format is they'll either escape it or they might quote it like this. So you might have something like this, like his age is 47, comma, there's his name. The comma is part of his name, not the separator, comma, his address, 123 Main, something like that. So what I'm doing can't deal with this. That's the reason why this library is very useful. But if I know that commas are only there to separate things, then what I'm showing you now works. Let's see what tokens look like. All right, so see it tokenized the line, got rid of the new line as well. And now I'm ready to start doing stuff. For T and tokens. I'm going to print the tokens. There's those numbers, and now I'm ready to sum. So instead of printing, I'm going to say my sum plus equal int, if they're ints, or float if they weren't, T. Let's see what the sum of those numbers are. 28. So that's what it took. Get a line, tokenize the line, and then for each token, turn it into an actual integer as opposed to something that looks like a number, and add it to the sum. So here's one example of using the CSV library. So I have to import it. But notice this. This line is the same. This line is the same. And now I have this right here. Reader equals, and this is a variable name, reader equals csv.reader at the file pointer. Now this right here is an object. So if I try to look at it, it's going to be like when I look at a file pointer. It's going to tell me something that doesn't help me. But I can iterate through it. So if we modify my code here, so we could call it R, for example. Just print what R looks like. See, underscore csv.reader object. So that's not something I can work with. But I can do this. For line in R. So this is not saving the whole thing. I'm going through the lines until I close it. Oops, did I say this? So see, it's already tokenized for me and got rid of the new lines. Okay. Now what if I want to read it in? Well, I can do this. I can take that reader object and save it like this. And so it converts it into a list. And now I can work with data like before. In fact, I think I just told you something wrong. Let's check that and see. Let's see if this still exists. I think it probably does. Nope. See, I closed the file, so I did tell you the right thing. It's use it or lose it. So I need to close after the fact. But if I want to save it, that's what I'm getting at here. See, it's a two-dimensional list, right? Because see the two square brackets? So this is the first row of tokens, which is a list, and the second row of tokens, which is another list. And then I can go through those. And then I don't need to tokenize anymore. I could process the individual elements for, so C in line. Now note these are still strings, so if I want to do math with them, I still have to convert those to integers. So they look like numbers, but they're not numbers. They're strings using digit characters. So that's really all there is to reading and writing files, at least at the most basic level. Now you can get into more complex situations in which you have to deal with the underlying file format, and in many cases you actually would want to deal with potential errors. So if you're unable to open the file, you want to try to deal with the error message that you would get, because there is a way to catch errors and tell the user there was an error or do something about it, as opposed to just crashing, which is what my programs have been doing up till now when there was a problem. So whenever I did something that was wrong, like here, It just had to crash. There are ways to catch the errors and say, hey, is this what you meant to do? Or let's try something else or whatever. But that's the basic process.